Hello everyone. So today we are going to work on this is the second part of the Flappy Bird C++ series that I'm working on. So today we are going to set up this built-ins class with few parameters to like number of pillars, pillar gaps. So if I change the gap to like 500, you can see these pillars with different heights will be spawned like this. So this will be later on used to move to the left side so that our character can jump over it. At the moment they are not moving yet. We are just going to work on how to spawn these pillars through the code using C++. So yeah, let's see how to do that today. Right, now we do have a basic bird character implemented with C++, which we can use space to make it like jump in this space. So yeah, and the next part is the buildings that scrolls across the screen to the right, to the left. So that's what I want to implement next. So for that, also let's add a new C++ class. So this time I'll choose actor because those buildings are just an actor. That's something that exists in the world. They are not something that is controlled by the player or no any inputs are required. So actor is fine. I'll name it buildings. Oh wait, buildings. Create class. Add in code to the project. Okay, now I have to reload to appear the newly added class. So we have buildings.h header file and building.cpp. So we need couple of variables here. So the way I am planning to implement this is just cubes, nothing fancy, just some cubes as buildings laid out in an array, and I'm going to move them to the left, and then when they reach some point, when they leave the screen from the left side, and again I'm gonna reposition them in the right side outside the view of the screen and move them back again across the screen. So that's what I'm planning to do. And yeah, so what are the variables we might need? Let me start a private section. And yeah, first I need an array to hold the references or pointers to the cubes that I create, and that has to be a U property because I need to see them when I create a class from this, when I create a blueprint from this class. So U property visible anywhere array this is going to be a set of pointers of static mesh components. So use static mesh component pointers. Let's actually, they are not really built-ins when I think about it in Flappy Bird. They are more like some pillars, so let's call them pillars. So but I have already named the class buildings, so I'm not going to change that now. Pillars. And okay, we will need another U property to define the number of pillars we need. So edit default. By using edit defaults only, we can make this variable only changeable the default values of the blueprints. We can't change the values for each instance of the blueprint. So int num of pillars, let's add the default value 10. What else we need? Yeah, we need let me copy this. For your property specifier, we need a way to define the distance between two pillars. So float pillar gap, let's say 100 units float, and we need we need a way to set the mesh that we are going to use for each of these static mesh components. So I'll create a reference to a static mesh that we can set as a variable, and we can use it to initialize the static mesh components we create. So use static mesh pointer pillar mesh, and I'll create a root component also here, because I remember last time we had some bonus regarding root. So let's just add a root component also manually, and I'm going to attach the pillar meshes that I'm going to create into this root component. Okay, and we need another function to place or spawn those pillars. So u function, actually this I don't really need this to be able to call from blueprints, but maybe for testing purposes we might need it. So I'll make it blueprint callable. Function name void spawn pillars, and here we get the option to create a function for us in the C++ class. Let's do that. What else do we need? Where are we going to call this spawn pillars? Should we call it in the construction or begin play? Definitely not in the tick, because we only need to spawn them once. But if I call it in the begin play, if I spawn the pillars on the begin play, then we wouldn't see them in the level before we start playing. So I can also call it inside the constructor, but if I call it inside the constructor, these variables that I initialize through the blueprint will not be available. The values will not be available when I am calling this spawn pillars through the constructor. So we need to call this from what we have as the construction script in the blueprint. So that means every time we change a variable, it will cause this spawn pillars to call. So to do that, inside C++, there is this onConstruction function that we can override. So this is an already existing function, so we have to override it. Virtual void onConstruction construction. Actually this is, can you get an autocomplete? Oh, IntelliSense is still loading. Let's give it a minute. Still no autocomplete. Okay, on construction, this function is const f transform and transform. This is how it is defined. Right, because we are already in an existing function. Okay, now we got the option to create it. All right, so here I am planning to call spawn pillars. So whenever I change a variable or something, this should be called. But we still don't have any implementation here. But to test, log temp. Let's put a simple one text spawning fellas. Okay, right, now let's head to the project, compile and see if we get any errors. Okay, compilation complete. Let's see. Buildings. Let's create a blueprint class from this name pp buildings. Oh, I should have called pillars, but doesn't matter. Right, created. Let me open it and see. Yeah, we have number of pillars, pillar gap and pillar mesh. Great. So for the pillar mesh, I want to have a cube. So where the cubes are, let's make a copy of the cubes in engine content. This one, copy here, don't move because it's engine content. Let's have some different color for that also. Green. Right. Okay, maybe true right, but that's okay for now. Now let's use this cube as the pillar mesh. So let's place buildings here. Now I should see, yeah, spawning pillars. I'm seeing this because every time I do some change, that spawn pillar function is being called, but I am still not actually spawning anything. So let's implement that now. Where is it? Here. So before we spawn, since we are doing this in the construction script, yeah, you know, as I showed you, every time we make some change to the blueprint, this function will be called. So there may be pillar components, static mesh components, that is already created from the way that we are going to implement this. So therefore, first I will create a loop, or maybe it's no need to do that now. I'll do it later. So let's first do the spawning part. So let's implement a for loop. Size ti equals 0 and length should be less than num of pillars, a variable that we have already defined. Right, so now we need to create a static mesh component. So let's first create a pointer. Use static mesh component smc. Let's use the name smc, stands for static mesh component. So there is a function called add component by class. So first we need to give t subclass of, so basically a class reference. So use static mesh component static class. This will give us a reference to the class type. And then what's next? Manual attachment. Let's make it false because we are, wait, let's just try false, but I'm not 100% sure. And we need to give a relative transform. Let's just give self transform with the default constructor. So I think that should be 0 0 for location and 0 0 for rotation, and for the scale it should be 1. What's next? Pull deferred finish. I'm not sure actually what that is, but let's give true. But still we have an error. Value of uActor component cannot be initialized an entity of type use static mesh component. So here static mesh component, but this is an actor component. This returns an actor component. So let's do a casting. Use static mesh component. Okay, we can safely do a casting because the static mesh component is a subclass of actor component. Otherwise we can't do that. So all right, so there are a couple of things that we need to do to make this component work. First, we need to check if we have a valid component. In any case, this is not a spawned, we wouldn't have it, so we will run into errors if we try to call anything on this. So smc register component, we need to call it to register with the actor, and we are going to move the pillars to the left of the screen. So they should be we need to set them movable. So smc set mobility a component mobility. We can already see what we need to use. So in a component mobility, yeah, we should have, yeah, see, we can set it to movable, and we need to attach this to the root component, but we didn't create a root component yet. So let's go into, where is the construction script, constructor of the class. All right, here. Oh, sorry, this is not where I should have implemented this. Really sorry. Let's implement it here. We should have implemented that there. Okay, so here let's create root equals create default sub object using component text name is root. Okay, now we can use it here. smc attach to component root. Oh, something is missing. Yeah, we need to define if attachment transform rules. If attachment transform rules snap to target, not including scale. So yeah, let's try that. Even if we include the scales, it wouldn't matter if the root scale is 111. Okay, now after attaching this, let's set the world location of this component. smc set world location, new location f vector. Well, we can simplify things if we just add some offset into the current actor location of the building's actor. So this dot get actor location. I think even if I don't use this, it should work fine. Yeah, it works fine. And add new f vector. We don't need to change anything in x direction, so 0, but we need to add an offset for each individual element in the pillars array. So we have already defined this pillar gap, so pillar gap multiplied by I from this side, so we can have a different offset for each individual element in the array. And on the z also we don't need any offset, so 0. Right, is that all? Yeah, that's all. What else? Oh, one more thing, we need to set the static mesh. smc set static mesh pillar mesh. Finally, I'll add this static mesh component into the pillars array. So pillars add smc. Right, we did a lot of stuff, so it's a good time to compile and see. Okay, compiled. Oh, we can see the pillars, but we can see the pillars also. Here more than 10 pillars are there, but if I make a change, see, there is already 30. If where can I change the number? So this number of pillars, it's edit defaults only, so we can only change it inside here, and the pillar gap also same. So let's make it 1000. Right, now it kind of works. See, so what's this error? Oh, call stack. Right, and you can see this has become 50 now. So which is so that's why I earlier mentioned that we might have some already created pillars in this array. So we should, before we try to create new one, we should destroy existing ones. So for size di I less than pillars dot now I plus plus pillars pillars I. So we can get a reference destroy component. So we need to delete the components, the static mesh components that we already have before creating, and after destroying all of them, we can empty the array. Pillars empty. All right, now that should have fixed the issue we had with this having so many arrays, so more elements than the number of pillars we need, which is 10. Okay, looks stuck. Oh, all right, it crashed. All right, before we attempt to destroy it, we should check if pillars I, if we have a valid element here, otherwise we shouldn't try to destroy it. Right, so after this change and compiling and restarting and compiling the project, now you can see the pillars number is here 10, and performance is also better because not an infinite number of not a lot of number of cubes are spawned. So yeah, definitely better. Right, now let's work on moving them to the right side, to the left side of the screen when I play the game. At the moment nothing happens, they just stay there. Okay, so for that let's add, oh no, maybe just for this episode let's not do that because it has already taken like 30 minutes. But let me do one thing. Let me change this num of villas to edit anywhere, this one, and villa gap also, and static mesh is fine, this is also fine. Let's do some height randomization. SMC set world scale, no suggestions. This is still running, that's why. Okay, that is complete. Set world scale 3D. So this is an F vector. I don't want to change the X scale, so 1, and Y scale also I don't want to change, so 1. How do I need to put 1.f because float values, and is it we need to, oh, these are double. Float is it we need to change, we need to have some randomization, so we can use fmath rand range minimum should be 1, maximum should be, let's say, 4. Did I miss anything? Yeah, one more bracket is required. Okay, let's compile. So we should see some randomization of the heights of these mesh components. Right, compilation complete. So you can see these pillars with different heights. So, and also now that I have made these variables edit anywhere, I can change the gaps here too and see how they change. Number of pillars 21%. Yeah, it does change, but over there, see. Okay, all right, so too close. Okay, so yeah, I'm gonna stop this episode right here. In the next time I'm gonna work on making them move here. Oh, when I move them here you can see the pillars change because the construction spawn pillar is called in the construction script, but yeah, that won't happen when I move them through the code in the runtime. So yeah, I'm going to stop this episode right here, and thanks for watching. As always, project files will be available here for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.